All right, learning target 6 says that we're going to verify identities. These are not as hard as learning target 4 because you at least have a starting point. Okay? So the first one says to find the sine of 90 degrees plus A and show that it's equal to cosine of A. Well, I can't do anything with cosine of A. It's just cosine of A. But I do have an identity I can use for sine of the quantity 90 plus A. So I'm going to use the sum identity for sine, which are the ones you guys have on the front of the note sheet. So 90 would be your alpha and A would be your beta, your two variables we've been working with. And so it says, if you follow along with the identity, it says to find the sine of alpha, so that's 90 in this case, times the cosine of beta, so that's capital A in this case. So for the sum, it says we still add, so then cosine of alpha times the sine of beta, which is an A. Does everyone know where I got those from? Again, I'm using the sum identity on the front of your note sheet. This is the sum identity for sine. There's a sine alpha, a cosine beta, a cosine alpha, and a sine beta. I just filled it in. You have that as a starting point, so you're filling it. Other questions up to this point? Using your unit circle, the sine of 90 degrees is 1. And the cosine of 90 degrees is 0. So 0 times sine A is just 0. And 1 times cosine A is just cosine A. So cosine A equals cosine A. Sine of 90. These are actual values on your unit circle that can be replaced with numerical values from the unit circle. So I take what I'm given, it's sine of something plus something. You should recognize at this point, after all the ones we've done, that would lead to using a sum identity. And then you would fill in the identity and simplify. It's 0 times sine A. So that's 0. Questions? On the next one, do not write what I'm about to write. I'm not telling you to start writing again. Okay? Excellent. It says tangent of theta plus pi over 2. Again, at this point, after working with these identities, you should know that means I should use an identity for some identity for tangent. So it says you would do tangent, again, this is alpha and beta. So you would do tangent of alpha plus tangent of pi over 2, which is beta, over 1 minus the tangent of alpha times the tangent of pi over 2. Looking at your unit circle, though, what's the tangent of pi over 2? What's the tangent of pi over 2? 1 over 0, which is undefined. It's undefined, so I can't do anything with this. Right? Undefined means it's undefined, means you don't know what it is. So this method is not going to work because I cannot do anything else with it. I have tangent theta plus undefined. Well, I don't know what that means, so that's not going to help me get negative cotangent. It's not happening. So, instead, we're going to do something different. So you can write this part down. What do we know about tangent? It's sine over cosine. So we're going to change this to sine of theta plus pi over 2 over cosine
of theta plus pi over 2.
Both of those have separate identities. So we're going to use identity for sine in the numerator and identity for cosine in the denominator. Okay?
Your theta is going to be your alpha, and your pi over 2 is going to be your beta.
If you're following the variables that exist in the identity.
So, for sine, we'll start there.
It says sine of alpha, so that's sine theta,
Times cosine of beta, so cosine of pi over 2, plus cosine of alpha times sine of beta.
Anyone confused about where that came from? I did not FOIL. I used the identity. In the denominator, I'm using cosine. So cosine of theta plus, or alpha plus beta. You have cosine of alpha, so that's cosine theta, times cosine of beta, so cosine of pi over 2, minus sine of alpha times sine of beta. The identity says if we're doing the sum identity for cosine, there's a minus sign in the middle. I know, so cosine, the plus sign's on top, the minus sign's on top too. Questions about where those two came from, the numerator and the denominator? Alright, now, all the places where we have cosine of pi over 2 and sine of pi over 2, those are actual values from the unit circle. So what is the cosine of pi over 2?
0. So whenever you see cosine of pi over 2, that's 0. Sine of pi over 2 is 1. So sine theta times 0 is just 0. Cosine of theta times cosine of pi over 2, that's cosine theta times 0, so that's 0. So I have cosine theta times 1. So what's cosine theta times 1? Cosine theta. And then I have negative sine theta times 1. So what's negative sine theta times 1? And what's cosine theta over sine theta? Cotangent. And there's a negative, so I'll make it negative cotangent theta. Questions on this one? This part? We tried tangent, it didn't work, so it got undefined. So to change it to something. So tangent is sine over cosine. No, so I would have tried tangent first too and gotten nowhere and had to start over. Right. Other questions on this one? Can I erase it? On the last one, I have sine of x minus y. That's going to be a sum identity for sine. So we could rewrite that, which we're probably going to. Then the other side, we're also going to have to rewrite because that's a whole lot of craziness. But first, let's look at the left-hand side. So I'm just going to be writing the sum identity using x and y's instead of alphas and betas. So I'm going to follow the sum identity from your notes. Because the difference identity, you're right, it's minus sign. So I have sine of alpha, which is x, times cosine of beta, which is y, minus the cosine of x times the sine of y. That's what this half is. That's what it says. That is the identity. We're just putting x's and y's instead of alphas and betas. We're using the difference identity for sine, because that's what this says. Find the difference between two angles. Yes, because it's sine. Since there's a minus sign, and we're finding the difference, we use the signs on the bottom, so we get a minus sign here too. Okay. On the other side, because there's nothing else I can do to this side. That's it. On the other side, what would be a strategy to use when I have cotangent, tangent, cosecant, and secant? Change them to what? So change them to sine and cosine. Sounds good. So I have 1 minus cotangent is cosine over sine, right? Notice your variables. So I've got cosine x over sine x times tangent is sine over cosine, so sine y over cosine y. Cosine x and cosine y are not the same thing, so they cannot be canceled out. It's like having 30 degrees plus 45 degrees, or 30 degrees minus 45 degrees. They're not the same. In the denominator, we have cosecant, that's 1 over sine, times secant is 1 over cosine. All right, so we're going to simplify some things. So in the denominator, we have 1 over sine x cosine y. I just multiply the two fractions in the denominator. Well, they're being multiplied, so I just multiply these two. I put them together in one fraction. All right. Then I'm going to multiply by the reciprocal. So I have 1 minus cosine x sine x times sine y over cosine y. That quantity times sine x cosine y over 1. So I'm not going to write the over 1 part. Just multiplying by the reciprocal. I haven't done anything, I just multiply by the reciprocal. All right, since there's a minus sign here, I'm going to distribute. So what is 1 times sine x cosine y? Sine x cosine y, right? Yeah. I just multiplied sine x cosine y times 1. For the second part, I'm going to write this all out so you see what happens. instead of talking it out. So right now I have cosine x over sine x times sine y over cosine y, and I'm multiplying that by sine x cosine y over 1. So the green arrow is what I have written down. I distributed. Now I should be able to cancel some things out. There's a sine x in the numerator here, and there's a sine x in the denominator here. So this is all the stuff in green is being multiplied together. I can cancel those out. There's a cosine y in the numerator here, and cosine y in the denominator here. So that's all being multiplied together. I can cancel those out. So I'm left with sine x cosine y minus cosine x sine y. I'll move it back in a second. But that's what you should have started off with, right? For all the Learning Target 6 questions. Because I guarantee you, some of you guys haven't been listening or have half listened, and I guarantee someone will do the following. Someone will get something like this, which we just rewrote as an identity, but someone will think that they don't need to look at their notes or don't need identities, and they will rewrite this as this, and they will be wrong. Whenever it says sine, cosine, tangent of something minus something or something plus something in the parentheses, it's a sum or difference identity, which is more complex than just distributing how your mind would think it is. Now, again, for these verifying identities, like Learning Target 4, they were like impossible because you didn't know where to start. Here, on every single one of them, you should know how to start because somewhere there's going to be a sum or difference, and you're just going to fill out that identity. So at least gives you somewhere to start with. Okay? Questions?